Good evening, friends. So this basically is a JEE 2019 question, a pretty lengthy one. In fact, is completing almost the entire screen. The solution is available in the entire internet space, but the idea of doing this video right now is to give you an aspect that how could you think of that solution. So just go through the question. There are six matrices. P1 is obviously I, they have mentioned it clearly. P2, P3, P4, P5, P6. All having each row's elements 1 and zeros. So that means there is one single one in a row or a column and all other elements are 0. This is the observation that you have to make, and then they have defined a matrix X which is summation of 6 matrices products, where the first side of the matrix is the 6 matrices. Then we have another matrix in between which also is a symmetric matrix, and then the transpose as they define of the matrix. If such Herculean effort is to be done to get X, then it is a multi-choice correct, another challenge. So that means you are not supposed to reject options, you have to evaluate each and every option. X into a column matrix is alpha times the same column matrix, then alpha is equal to X is a symmetric matrix. Sum of diagonal entries of X is 18 and X minus 30 I is an invertible matrix. After looking at this entire question, if I were in your place, the first thing that would have struck to me is that probably something is definitely going to happen when I multiply this column matrix 1, 1, 1 to this entire X. So I start my working from there. Let me say X is equal to summation Pk. I will not write 1 to 6, that is obvious. And I will write this matrix, let me call this as A into Pk transpose. And in this X, if I think of multiplying another matrix, say B, would take lesser space. What is B? B is nothing but your column matrix 1, 1, 1. So since there is an option which is guiding something of this sort to happen, so I start my working with this. Let me find XB, which is summation of this. Now I can pretty well write K is equal to 1 to 6. What I realize is that the transpose of any of these matrices would also have 1, 1 in the row or column, and all other elements would be 0. In fact, if I look at this, so except P4 and P5, probably all matrices are symmetric. So there basically transpose is the matrix itself. So in that case, I realize that when Pk transpose is multiplied by B, this gives me again B. So I can probably say that this is summation K is equal to 1 to 6 Pk into A into B. And A into B is not varying as per the values of K, because that's a fixed matrix. So I can write that separately, evaluate 2, 1, 3, 1, 0, 2, 3, 2, 1, multiplied by your column matrix 1, 1, 1. And as we do in the row column operation, I probably get this matrix as 6, 3, 6. Let me just check. 6, yeah, 3 and 6. So what I realize is that this is a single column matrix and the summation goes over this. So isn't this okay to conclude that if I multiply all these 6 matrices sum with this final matrix 6, 6, I'll get X into B. So what I get X into B is summation of this 6 matrices, which basically is I guess it is, yeah, 2, 2, 2, because in all of this 6 at every pace 1 has comes twice and other all elements are 0. So this becomes this matrix into your 6, 3, 6. And if I evaluate this, this comes out to be 12 plus 12 plus 6, 24 plus 6, that is 30, irrespective, because all the rows are same. 30, 30, 30, and the trick worked. What guided me was this option. So I understand that this option definitely is correct, because this is 30 times I. I also suddenly realized that x minus 30 times, in fact, this is 30 times b. So x minus 30 times I into b with matrix is a null matrix. Now, if I try to solve a matrix equation with three variables, so this right hand side being a null matrix has the trivial solution, and that trivial solution is none other than, if I take three variables for this matrix x minus 3i, 30i, so that is basically 0, 0, 0, but has another solution, and that solution is none other than your b, which is 1, 1, 1. So just assume that instead of b, you take that column matrix x, y, z of variables, and this is the coefficient matrix of a matrix equation, a homogeneous matrix equation with a right hand side d1, d2, d3, 0. So for a homogeneous matrix equation, one solution obviously exists, that is basically 0, 0, 0. Another solution by virtue of this equation exists. That means this is bound to have infinite solution, which means the determinant of the coefficient matrix has to be 0, which clearly rules out this option. So I have two of my options done. This is a more than one choice question, so in such questions you need to be very selective instead of just jumping to all options. In case you are not sure about any particular option, leave it as it is, because you get penalized if you just touch a wrong option. Now let me go through the other options. X is a symmetric matrix, so I guess this is pretty obvious to observe, because when I talk about X, all these matrices are symmetric, so when we multiply them we get a result symmetric, except this P4 and P5. But what we need to observe is that transpose of P4 is P5 and transpose of P5 is probably P4. Just have a look and check. 0, 1, 0, 0, 0, 1 and this 0, 0, 1. Yeah, so that means when I take that commutative sum, so the transpose order in totality, they might not be a symmetric matrix as a component, but their sum is definitely symmetric, so I take the option B also. Last one to check, the sum of diagonal elements of X is 18. Now if you look at any of these elements, when we multiply one of these sides, because all the elements are 1, 0, 0, 0, 1, 0, so that means when we take the product by the matrix multiplication, we realize that these 1, 0, 0 doesn't change the value of the trace of this matrix or the sum of diagonal elements. Further, when that multiplies with 1, 0, 0 here, doesn't change the, so that means irrespective of pk and pk transpose, the trace remains to be same. What is the trace of this matrix? So to say A, which is the sum of diagonal elements 3, and it happens 6 times in each of these cases, so this becomes 6 into 3, 18. So this essentially is correct by virtue of the data given in these 6 matrices. Any such question coming into JEE which is extremely lengthy and you are not in a position to decide, I recommend you look into the options. Try to find that link which basically gives you the starting point where to start from, and at any stage be very cautious, be very alert. There is no need to attempt the entire question or take a decision on all the options, because the moment you touch a wrong option you get penalized. Had it been that you had only taken 2A, B correct, which were easy, and you couldn't decide on C, but you could decide on D, or you maybe not have decided on D also, just leave it with A and B as correct, which are confident. You would at least get some part marking. The moment you touch D, which is a wrong option, it's all over. You either get 0 or negative depending upon the paper. So pretty well good. Thank you.